problem on page 14 that you had for homework last night, especially 14, this problem 3C. Yes. So that's a problem that I need to make sure that you have a handle on, because this problem 3C is going to also be like the problem number 5. And then there will also be a problem like this on your warm-up, and a problem like this on the quiz and on the test. So this definitely is a problem that I expect you to be able to do. And so right now I'm going to carefully go through it so that I got some strategies to teach you of like some steps you can do to make sure you got this down. So here we go. So this problem started out with two different liquids, the liquid Q and liquid W, and the viscosity and how long it takes for them to travel a particular distance. And so it gives us, this problem starts off giving us this information here about fluid Q and fluid W. All right, so my first question is, it says find the expected value of their difference. And so difference, of course, means to do what? Subtract. All right. So my first question is, I'm going to take a poll. How many of you did W minus Q versus Q minus W? I want to see how many did W minus Q when you subtracted. Okay, good. Yep. And how many of you did Q minus W? Okay, just a couple. All right, so I'm going to demonstrate the class with W minus Q. If you did Q minus W, your results will be the same in the end. It's just that all your pictures will be flip-flopped backwards, and your numbers will be the negative instead of the positive and that kind of thing. All right. So we're going to go with the expected value of W minus Q, and that's probably what I would have done, because I kind of like to deal with positive numbers instead of the negatives. So then when we're doing the standard deviation of W minus Q, remember when we talked about the cereal box and the cereal bowl, even if you were subtracting out and finding a difference, the uncertainty still did what? Even if you subtracted, the variability still added. And so there was the standard deviation of statistics, making sure you still added right there. And that was 3.61 seconds. All right. So those were basic. You should have been able to get those. It's here when we get to this problem, 3C, that I want to give you a technique to follow. So here we go. So first, find the probability that type Q would actually be slower than W. So let's first draw a normal model. And step number 1, label, and this is critical. It's actually a very important step to not overlook. You have to write down the way that you subtract. Did you do W minus Q or Q minus W? And we did W minus Q. That actually makes a difference. That is an important step to consciously make an effort to pay attention to. All right, so that's the first thing. Write down the way in which you're going to subtract. The second thing, actually, hold on. Let me go ahead and put my number in here. The 4 was the middle, right? That was the mean. 4 was the mean. Okay. Second thing, let's put in the 0 difference. Where are W and Q equal? At 0, where would 0 be? To the left of 4. So I don't know exactly where, but it's somewhere over here to the left. This is a difference of 0, and that, of course, is where W equals Q.
So you're just doing it different on this model, because up there you said W minus Q, but then once you put them in the square root, it's actually the Q plus.
That is having this be plus is something, a quality we learned yesterday, right, that even if you subtract, the standard deviation still becomes bigger.
Right. I was just saying,
No. So we're doing W minus Q. I've not changed that. It's W minus Q the whole time. All right. So now here comes the next thing. So number 1, write down the way you subtract. Number 2, put down where the 0 is, the 0 difference is. Number 3, now we're going to define what's bigger on which side of the 0. So here's what I mean by that. So over here on this side, these are positive differences. This section is where W minus Q is a positive number. Okay, do you agree with that statement?
yes.
All right, so if W minus Q is a positive number, which is the bigger number, W or Q?
W.
Then the first number is bigger. Because if you subtract and the first number is bigger, then W is, and the subtraction is a positive number, then W is a bigger number than Q. All right, let's do the flip side. So over here on the left, this is a situation where we had negative differences. So W minus Q equals a negative number. So if W minus Q is a negative number, then when you subtract and you get a negative difference, which is the bigger value, W or Q?
Q.
Yes, because if you subtract away a bigger number, then you get a negative. Q is bigger than W. All right. So that's the 3 things to get you going on this problem, and from here on out, it'll be very simple. So let me review. Number 1, put down what the differences were. Number 2, put down where the 0 line is. And number 3, define what's bigger on each side. Now we can answer the question. The question is, what's the probability that Q is slower than W? If Q is slower than W, then what do you know about its time?
It's greater.
It's greater. So we want to know the probability that Q is greater than W. And so according to this picture, where is that section? The left or the right of the 0? Yes, you just found that this is what I'm actually going for over here on the left. So we're now going to work out that problem. And how are we going to do that? A z-score. And we're going to get a z-score. 0 is the x minus the mean over the standard deviation, and that is negative 1.11. And then I want to have this lower section, so I'm going to norm CDF from negative 99 up to that negative 1.11, and that's how you get whatever that number is, and I don't know. 0.133, okay. 13.3 something percent. Okay. All right, so that is the gist. And so I want you to look down at problem number 5. Let's take a look at problem number 5. Okay, so by the way, problem number 4 was not difficult, was not intended to be any like special difficulty. Problem number 4 was a simple normal model where you had a mean of 560 and you were finding out 750 or more, okay? So that one was a pretty straightforward one. You z-score and norm CDF above. But here is another one about the difference. What's the probability that I will make more than my brother James? So we start off. James makes $2.60 more than me. So on average, James minus Mary is $2.60. And the standard deviation for James minus Mary, it is told to me in this problem, is 246. So essentially, they already did the parts A and B for you, like above. So now you go through this process that is centered at 260. What's the first thing you do? Write down how you subtracted, and then find the 0, and then find what's bigger on each side. All right, so I'm going to leave you be on that one. And your assignment for today, so I want you to work out that number 5 and finish what you had not finished. Your homework, which actually you most likely will be able to finish in class, is pages 15 and 16. That is the warm-up. And tomorrow we'll go over all our stuff and we will quiz. Now, I'm going to tell you that tomorrow's homework is pages 17 and 18. So if for some reason, since 15 and 16 can be done in class, depending on how fast you are, which some of you guys are going to be able to get 15 and 16 done fairly quickly, then you could even get on to 17 and 18 in class. And heck, you could even do part of it today and part of it tomorrow after the quiz and not even have homework tomorrow night either. So if you were real diligent in taking care of your business, you could almost have no homework 2 nights in a row. All right, that's it for those. I will come around and stamp you while you are working.